Howdy y'all. In this video we're going to talk about the other method of determining validity, which is the proof method or the derivation method. And what we're going to discuss today is how to do these derivations or proofs with the rules of inference. So there's the rules of inference and the rules of replacement. We're going to be talking about the rules of inference. Okay, so for a number of you, this will be your first introduction to proofs. And in logic, a proof is a way to show how a conclusion of an argument can be derived through a series of steps from a set of premises. And such a derivation will show us that the argument is valid. So the idea is if you can do this, that means you're dealing with a valid argument. And if you can't do it, well, that means the argument is invalid. But this is just primarily a test for validity. So every argument that we're going to be given is going to be provable. That this is going to be a thing that you will be able to do, even though that there exist arguments where you wouldn't be able to do it. So doing this derivation requires a set of rules to tell us which steps are permissible in the process. So we have to be sort of justified in whatever step we make, and the rules will tell us which steps we can take. And the rules that we're sort of discussing are called the rules of inference, as I mentioned at the outset. So there are also this sort of set of the rules of replacement that you'll find in the text, but we're just going to concern ourselves with the rules of inference. So when you do a proof, and I'm going to show you how to do that in just a second, you need to show each step of the process and the rule that justified that step. So here's an example, and before we start the proof here, I just want to kind of explain to you sort of what's going on. So when we're given an argument in this section, you're always going to have the premises will be on the left, and they're sort of listed and numbered. And that's going to be important, as you're going to see, because they're going to be part of this kind of step-by-step process. And on the right, next to the three dots, which is the therefore symbol, you see a D, and in this case, that is our conclusion. So the D is the thing that we're going to try to derive. So if we can get to D, we will have shown that, yes, indeed, D is derivable from this set of premises, and therefore this argument is valid. So the way this works, and we'll get into more detail here in a second, but just to kind of show you the whole process, the way that this works is that we add lines to this list. So we have these sort of premises, and using the rules, we can modify these premises or use these premises to generate new lines, and we're going to keep on doing that until we can get to the conclusion. So for instance, one of the rules that we're going to discuss is a rule called simplification. And what simplification lets you do is take any conjunction and break it apart. So line 1, or premise 1, is a conjunction. So the simplification rule says, well, look, I can either put A on a line or not B, right? I can break this into its component parts, which is A and not B. So I already know how this goes, so I'm going to just go ahead and put not B. I'm going to use the simplification rule on line 1, and I'm going to break it apart. And so what I do is I write not B, right, and I'm allowed to do that because of simplification. So I'm going to tell my audience what I did. So I used the simplification rule on line 1. So typically you say what line you used and then what rule you used. And this is called the justification. and it lets the author or the audience know if you did it correctly. So I have not be now, and that's can be used along with the rest of these things to generate sort of new lines. And I'm trying to get to D, and there's two more steps that need to happen. So the first step involves a rule that you've heard of before, which is modus tollens. Modus tollens says that if you have a conditional, and if you have a negation of the consequent of that conditional, then you can get the negation of the antecedent of that conditional. So if P, then Q, not Q, therefore not P, right? We know that that is a valid form. And if you look at line 2 and if you look at line 4, that is an instance of that kind of pattern, right? We have a conditional in line 2, and in line 4 we have the negation of the consequent of that conditional, right? That's not B. And so what we can derive is the negation of the antecedent of that conditional, which in this case is not C. So the rule I'm using is modus tollens, and the lines that sort of were involved were 2 and 4. So again, that's kind of what my justification is. So simplification only requires one line, but modus tollens requires 2. Okay, so just about there to D. In fact, this next line is going to be D, because I can use line 5, I can use this not C along with line 3 in a different rule. So the different rule is disjunctive syllogism. Again, that is a pattern that we have discussed in chapter 3. It has a valid pattern. This is argument by elimination. So what disjunctive syllogism says is if you have a disjunction, right, an or sentence, and you can eliminate one of those disjuncts, right, in this case C, then you can derive the other. So in this case, C and D would be P or Q. Line 5 would be sort of not P, and then line 6, D, would be Q. It fits that sort of disjunctive syllogism pattern. So using the disjunctive syllogism rule, along with lines 3 and 5, I have derived the conclusion of this argument, and thus my proof is complete. So that's what we're doing. We're going to talk through the rules here, and then we'll do some more examples. Okay, so what we're going to do here is talk about the rules of inference, and there are going to be 7 of them that we're going to deal with. You could have more, you could have fewer, but we're gonna do 7. And on the left here, I have patterns that require 2 lines to work. That's sort of one aspect of them. And then the other is that they're patterns that you've sort of seen before. These are valid argument patterns that we discussed in chapter 3. So we're going to use these valid arguments as rules for our derivations. So we've got modus ponens, modus tollens, affirming the antecedent or denying the consequent. We have hypothetical syllogism or chain argument, and we have disjunctive syllogism or argument by elimination. So all of these rules, what they tell us is that if you have a line, let's start with modus ponens here. If you have a line that is a conditional, and you have a line that is the antecedent of that conditional, then you can derive, and this is what the sort of 3 dots is saying, then you can derive the consequent of that conditional. So whatever P is or Q is, it's going to change. It's not going to be P and Q. But if you have an antecedent of a conditional that's on a line, then you can derive the consequent of that conditional. That's what the modus ponens rule tells us. Similarly with modus tollens, the rule tells us that if you have a conditional and you have the denial of the consequent of that conditional, or if you have the negation of the consequent of that conditional, then you can derive the negation of the antecedent. So again, you need these two things. You need these two lines somewhere in your proof. But if you have them, then you can do this derivation. That's what the rule says. Hypothetical syllogism says that if you have a conditional and you have another conditional which has as its antecedent the consequent of the other, then you can derive the antecedent of one and the consequent of the other, right? The one that isn't shared. So that's hypothetical syllogism. And then finally, disjunctive syllogism says that if you have a disjunction, so this is not an if-then sentence, this is an or sentence. If you have a disjunction and you have the negation of either of the disjuncts, so either not P or not Q, then you can derive the remainder, so Q or P. So not P will get you Q, not Q will get you P. So those are ones that we've seen before. On the right, though, we have some rules that we haven't discussed, some patterns that we haven't discussed. So one of them is simplification. Simplification is very easy because what simplification says is that if you have a conjunction, which is an and sentence, anywhere in your proof, then you can break it apart into its component parts. So if you have P and Q, you can put P on a line. If you have P and Q, you can put Q on a line, or you can derive Q. So that's easy. Whenever you see a line that is a conjunction, you can break it apart. Okay, so another rule is addition, and this is another rule that only requires one line instead of two, like the ones on the left require. Addition is kind of weird because what addition says is that you can take any line and add whatever you want to it, right? Like literally anything, as long as it's a sentence in the language, you can add it to your line. So whatever Q turns out to be, or whatever P is, if you have P on a line, you can either add Q afterwards or before. It doesn't matter. But what does matter is that you use a disjunction in order to do it. So it's only valid if you use a disjunction. If you use anything else, it's not going to work. So there you have it, addition. And then finally we have our conjunction rule. Our conjunction rule says that if I have two lines somewhere in my proof, I can put them together with the addition sign. So this is kind of like addition, but different. Sorry, not the addition sign, the and sign. So it's kind of like addition, where you're sort of making a more complicated sentence. But in this case, you can't just add whatever you want together. They have to be lines in your proof, right? So P and Q have to occur somewhere in the proof in order for this to work, right? To know that both P and Q, you have to have P by itself somewhere and Q by itself, and then you can put them together. All right, so those are the 7 rules, and we're going to use those 7 to do proofs. All right, so the best way to learn this is through examples. Just as I kind of walk through these, I'm going to talk to you about how to do proofs. So here's an example. Here's an argument with 3 premises, A and B, which is a conjunction, B arrow C, which is a conditional, and A arrow D, which is also a conditional. And what we're trying to do is to get C and D. So one of the things that you need to think about when you sort of do these proofs is sort of look at the goal and see where in the premises this goal is, or at least parts of this goal is going to be. So for instance, you should note that, you know, there's a C in line 2, there's a D in line 3. And if we could just kind of break 2 and 3 apart, well, then maybe we can, you know, do something, right? That's kind of typically when we sort of talk about proofs and working on the lines, we're either kind of putting things together or taking them apart. And in this case, what we're going to need to do is begin by taking things apart. So let's look at the premises here a little bit and see sort of what we can do. We have a conjunction and we have two conditionals. And so the way to start this, and this will become, you know, more obvious as we go along, but the way to start this is to break apart line 1. That really the only rule that we could do at this time is the simplification rule. Simplification allows us to take any line that is a conjunction, right, and any and sentence, and break it up into its component parts. So for line 4, I'm going to break up line 1 using the simplification rule. And with line 5, I'm going to get the other piece as well. So I'm going to simplify line 1 into both of its component parts. And the reason that I did that is because I need both A and B by themselves in order to do my next steps. So my third step here is going to be to use my A along with line 3 and to do the modus ponens rule. So the way that modus ponens works is that if you have a conditional and you have the antecedent of that conditional, right? So here's the conditional, A arrow D, here's the antecedent of that conditional, which is A, then you can derive the consequent of that conditional. So it's modus ponens, and it's with 3 and 4. So you should look at those two paragraphs, or excuse me, those two premises, and see that yes, indeed, that's a conditional, that's an antecedent of that conditional, and therefore the consequent of that conditional. And then we're going to do it again, this modus ponens rule, but with instead of 3 and 4, we can do it with 2 and 5. So 2 is also a conditional. 5 is also the antecedent of that conditional, and so we can derive the consequent. So 2 and 5 modus ponens gets us C. So now take a look here. With line 6 we've got D, line 7 we've got C, and the last thing that I'm going to do is I'm going to conjoin those two lines. I'm going to take 6 and 7 and put them together, or I should say 7 and 6, just to give you the order. I'm going to put them together using the conjunction rule, right? So the conjunction rule, as we mentioned, allows you to take any two lines, as long as they're in your proof, and put them together using the conjunction symbol, the and symbol. And that's how conjunction works, right? So if C is true and D is true, well, it must be the case that C and D is true. It's fairly straightforward. So by doing that, we have, you know, gotten to the end, right? That is the conclusion, and therefore the argument is valid. All right, here's another example. So I'm going to use just a couple rules here. This may be sort of a little bit complicated because of the parentheses, but the rules that I'm using are the same. So I've got A or B, arrow C. I've got A, and then I've got, as my goal, C arrow D. So one thing I want to sort of note about this, and this is something that's kind of a good strategy, but do note that D doesn't appear anywhere in the premises. So the D is going to kind of come out of nowhere, and that can happen. But the only rule that lets you take something or bring something out of nowhere is the addition rule. So keep that in mind as we sort of go forward. I'm going to use the addition rule a couple times in this proof, and one of the times I'm just going to bring it out of nowhere. But the first thing I'm going to do is addition, and that is because what I want is the antecedent of this conditional. So line 1 is a conditional, and this A or B is the antecedent of that conditional, and the C is the consequent. So if I can get the antecedent, I'll be able to get the consequent, which is C, and C is part of the conclusion that I want. So that is going to be sort of an important thing. So what I'm going to do is I'm going to add B to line 2. I can, addition allows you to add whatever you want, right? If it's in the argument, if it's not in the argument, all it has to do is be a sentence in the language, and you can add it to any line that you have. So in this case, I'm going to add it to line 2, and by doing that, I now have the antecedent of this conditional in line 1, right? So I now have a situation where I have P arrow Q, P, and what I can derive from the modus ponens rule is Q, and in this case our Q is C. So what I get is C from lines 1 and 3 and using the modus ponens rule. So I've got C all by itself, which is nice. And note that what I want is C or D, and as I mentioned before, addition allows you to add anything that you want to a sentence as long as you add it with the or. And given that that's what the conclusion is, that's what we're going to do. So C or D is just adding D to line 4. And that gets you the conclusion. So you're done. Isn't that nice? All right, here's a third example. So suppose we have A and not B, not C or B, and then D arrow C. So this is, we're adding some negations in here. Things might get sort of a little confusing, but nevertheless, our 7 rules will be able to, using our 7 rules, we'll be able to derive not D. So the first thing I'm going to do is I'm going to, because one of my premises is a conjunction, I'm going to break up that conjunction. So in this case, the conjunction is in line 1, right? We got A, and we got not B. I want not B. So that's all I'm going to get. I don't need A to do this proof. Although, if I wanted to, I could put it down there. Okay, so I need the not B because what I'm going to do is I'm going to use the not B along with line 2, or premise 2, to get not C. And this is through disjunctive syllogism. So disjunctive syllogism says if you have a disjunction, in this case not C or B, and you have the negation of one of those disjuncts, so that would be either not C or not B, then you can derive the other. So in this case, I'm going to have not B, which is the negation of B, and I will be able to derive the other disjunct, which in this case is not C. So I'm not negating the disjunct, right? The disjunct was already negated, but I am negating B, right? So B is not B is the negation of one of the disjuncts, which is B, and then the other disjunct is not C. I know that that's going to sound tricky at first, but trust me, eventually it's gonna click. So not C is what I get when I use 2 and 4 and the disjunctive syllogism rule. So 2 and 4 fit that disjunctive syllogism pattern, and so now I have not C. So now not C, having not C is good because I'm going to be able to use that with line 3 to do the modus tollens rule. The modus tollens rule says that if you have a conditional, which is line 3, and you have the consequent of that conditional, which is line 5, then, excuse me, if you have the negation of the consequent of that conditional, which is line 5, then you can get the negation of the antecedent. And in this case, that's not D, right? The negation of D is not D. And so, once again, we have derived our conclusion using our rules. And then this argument is valid. All right, 2 more examples, and I want to end here with some examples that are a little bit more complicated, require a little bit more work, and maybe a little bit more confusing. But let's start with this one over here. So here's an argument that has a lot of things going on. We've got A and not B, arrow not C, which is a complicated looking sentence. We have A and D, we have D arrow not B, and what we're trying to get is not C or E. So this is going to take a little bit longer, but I'm going to just kind of go quickly through this because I'm running out of time. And I want to start by using the simplification rule on line 2. I want to break line 2 apart. And I actually need both elements here, so I'm going to go ahead and do it twice. So I'll simplify line 2 to get A, and I'll simplify it again to get D. So the next step here is to get not B. So 3 is a conditional, and 5 is the antecedent of that conditional. So using modus ponens, I'll be able to get the consequent of the conditional. So note here that the consequent is not B. So what I get is not B. So now what I'm going to do is I'm going to conjoin lines 4 and 6. I'm going to, remember with conjunction you can take any 2 lines and put them together as long as they exist in your proof and you put them together with the conjunction symbol, right? This doesn't work with or if then. So once I've done that, what I can do next is get not C from line 1. Line 1 is a conditional. It may be hard to see because of the parentheses, but all that stuff at the beginning in the parentheses is the antecedent of the conditional, right? So A and not B is like the P, and the not C is like the Q. And if you'll note, with line 7, I have A and not B, right? So if I have A and not B, which is the antecedent of that conditional, then I can use modus ponens to derive the consequent of that conditional, which is, in this case, not C. Okay, I'm not quite done. I still need to not C or E, and this part's pretty easy because as long as you do it with an or symbol, you can add whatever you want to a line. So I'm just going to add E to line 8 and then be done. So C or E, excuse me, not the case at C or E, which is the conclusion. All right, one more, and that'll be it for this video. We have A and B or C. We have, oh, excuse me, sorry, not A or B or C. We have C arrow A, and then we have B or D arrow A. And the conclusion here is A and not A. So this one may be a little tricky, but again, just using our rules, it's doable. So I'm going to start, again, we have something that we can sort of break apart, which is line 1. So I'm going to start by breaking this conjunction apart with the simplification rule. So you get not A, and you get B or C, right? So these are the two conjuncts of that conjunction, right, in line 1, and so simplification lets you break that up. So if I do that, I can do the modus tollens rule on lines 2 and 4. Modus tollens says, you know, if you have a conditional, if you have the denial of the consequent of that conditional, then you can get the denial of the antecedent. You can get the negation of the antecedent. And so that gets me not C, and not C is good because I can use that along with line 5 and the disjunctive syllogism rule to get B. So 5 and 6, disjunctive syllogism. And then the next thing I'm going to do is I'm going to add D to line 7, because that is the antecedent of line 3, right? So line 3 is B or D arrow A, and so now I have the antecedent of that conditional, and so with the modus ponens rule, I'll be able to get A, right, which is the consequent of that conditional, right? So 3 and 8 make up the modus ponens pattern, so that will get me A. And then this will lead me to my final step, which is A and not A, which involves just conjoining lines 9 and line 4. And that is that. So the conjunction of 9 and 4 gets me the conclusion. So there it is, a number of derivations using these sort of 7 rules of inference, along with their justifications. We'll talk more about this in class, but this is how they work. So be on the lookout for more from me. Thank you.